So this video is on section 1.1, part 1, which is solving linear equations with one variable. So this first example asks us to solve negative 3x plus 9 equals 30. When we're solving equations, we need to do the opposite of the order of operations. So if you think of the order of operations as PEMDAS, and then you identify what you're solving for, which in this case our unknown is x, we need to start out by asking ourselves, is there anything added or subtracted to the x? And yes, there's this 9 right here that is added. So to undo this operation, I'm going to subtract 9 from both sides. I'm left with 9 minus 9 equals 0. So negative 3x is left on my left side, and 21 is left on my right side. Now, since there's no more addition or subtraction done to my unknown, I move on and say, well, is there anything multiplied or divided by my unknown? And yes, there's a 3 that is multiplied, or negative 3 that is multiplied by the x. So to undo that, I divide both sides by negative 3, and I'm left with x equals negative 7. You could also, if you wanted to double check your work, you could always take the answer that you got and plug it in for the x to confirm that it actually does equal the other side of the equation. So negative 3 times negative 7 would give me positive 21, plus 9 would indeed be 30. The next example is to solve this equation again, but at first it is not in simplest form. So before we start solving the problem, we're going to have to go ahead and simplify this problem. So I'm going to go to this innermost parentheses and take care of this multiplication of this negative 3 across this binomial by using the distributive property. So everything else is going to just come down for the ride. So the 3 minus the bracket, x, and then negative 3 times x gives me negative 3x. Negative 3 times the 2 is going to give me a negative 6. All equals 4. And now, kind of an intermittent step, I've got this x and a minus 3x. So if I have one thing and I subtract 3 of that same thing, I am left with just negative 2 of those things. So negative 2x right there. And everything else needs to come down. Minus the 6 equals 4. And so now, before I continue, again, I have a negative across a parentheses or a bracket. So I need to distribute that negative across this binomial. So I'll have the 3 come down for the ride. Negative and a negative gives me a positive 2x. Negative and a negative gives me a positive 6. Equals 4, and then my last step before solving is going to be combining these whole numbers. So I've got 3 and 6, so that gives me on the left side 2 x's plus 9 ones equals 4, and now finally we're simplified and it is exactly like the previous example, example 1. So now I want to solve for this x. I need to subtract the 9 from both sides. And I'm left with 2x equals negative 5. So dividing both sides by 2, I get that x equals negative 5 halves as my final answer. This next example, example 3, again, is not in its simplest form. So before we can solve for the unknown y, we need to get it's simplified, combine all our like terms, so all of our y variables and all our 1's. So again, going to the innermost, I'm going to start with the left side of the equation here. So let's actually just distribute this 3 across this binomial on the left side. That leaves me with 12y minus 9. And then on the right side of the equation, I'm actually going to first distribute onto this innermost parenthesis across this binomial, this negative. So everything else is going to come down for the ride, so 4y, and then negative and a positive 4 is going to give me negative 4y. Negative and a negative 3 is going to give me positive 3. Now my intermittent step is going to be to go ahead and simplify because I have a y and a negative 4y on the right side of the equation. So left side stays 12y minus 9, and then the right side is going to be 4, and then this bracket y, and negative 4y is going to give me negative 3y plus 3. So again, I have a single number multiplied by a binomial, so I need to distribute across on the right side of this equation. And again, you may not use every single one of these steps, but you need to make sure that you are not simplifying too much in your head because it just opens up the room for error whenever you're doing these kind of more complex calculations and solving problems. So, so distributing this 4 across this binomial, 4 times a negative 3 is going to give me negative 12y. And then the 4 times the positive 3 is going to give me plus 12. Okay, and then my next step before I can solve is going to be to combine, get all these y's onto the same side of the equation. So I'm going to add 12y to both sides. On the left side, that leaves me now with 24y minus 9. And then on the right side of the equation, negative 12y plus 12y is going to leave me with 0 on there. So equals just that plus 12. Now, finally, I can solve for this y right here. Okay, and so to do that, now I'm going to add 9 to both sides to get that y by itself. Negative 9 plus 9 gives me 0. I'm left with 24y equals 12 plus 9, which is 21. Then my next step, since I've got 24 times y, I'm going to divide both sides by 24, which gives me y equals 21 over 24, which I'm almost done, but that is actually not in simplest form. So I see that you could also do this in a calculator, but I see here that 21 and 24 both share a common factor of 3. So I could divide both the numerator and the denominator by 3, and that leaves me with y equaling 7/8 as my final answer. Okay, so for example number 4, so immediately when I see this problem, I see that I have some fractions. So the easiest way to solve these problems is to go ahead and get rid of those fractions so that we can just solve the single equation. And so the easiest way to do this, if you think about, there's actually a denominator there of 1. So we have 9, 6, and 1. And so my least common denominator amongst those three factors of 9, 6, and 1 is actually going to be 18, because 18 is a multiple of 6, it's a multiple of 9, and obviously it is also a multiple of 1. So once I know what my least common denominator is, I actually go ahead and multiply both sides of the equation by my least common denominator, which in this case is 18. So we're going to multiply both sides by 18. So that gives me 18 times the 2x plus 1. And I'm going to keep that numerator in parentheses. And then I'm going to multiply the 18 by, so that was by the first part. This is by the second part of the left side of the equation. So 18 times the x plus 4 over 6. And then my right side of my equations, 18 times 1 is actually just 18. And so now, instead of distributing and then resimplifying, which I could do, I'm just going to go ahead and say, well, 18 divided by 9 is just going to give me 2 times 2x plus 1 minus, and then 18 divided by 6 just gives me 3. So I'm just simplifying this part right here, times the x plus 4. And I can only do that because this is multiplication. It's 18 times something divided by 6. So I can just divide directly into that 18. So this all equals 18. And so now I just need to do some distribution. to simplify this problem and then solve for x. So here, distributing across this binomial, I've got 2 times 2x, which gives me 4x, plus 2 times 1, plus 2. Here I have, it's a negative 3. Don't forget about that negative. So negative 3 times x gives me a minus 3x. Negative 3 times 4 gives me a minus 12 equals 18. Now I'm going to combine like terms. I have 4x's and minus 3x's, so I only have 1x left. Then I have a plus 2 and a minus 12, so that's going to give me a minus 10 equals 18. So now I just have a very easy single-step problem. X minus 10 equals 18. Adding 10 to both sides. Some of you could have probably done that step in your head. X is going to equal 28 in this case. Example number 5 is similar again. We have this least common denominator that we need to find for, we've got a denominator of 3, a denominator of 2, and let's go ahead and we know that this is technically divided by 1. So my least common denominator is going to be the least common multiple of 3 and 2 and 1, which is going to be 6. So again, and there are other ways to kind of do this next step. Some of you might have a different method that works for you, as long as you're getting the same answer. That's all that matters. But again, I like to just multiply both the left side and the right side by that least common denominator. So here it's going to be times 6. So again, you have to distribute it to all parts of the left and right side of the equation. So that's going to give me 6 times x plus 2 divided by 3 minus 6 times x divided by 2 equals 5 times 6, which is 30. Okay. Which is 30. Okay. So then on the left side, 6 divided by 3 just gives me 2, parentheses, that x plus 2 still, minus 3x equals 30. Now I'm going to still need to distribute this 2 across this binomial, x plus 2. So 2 times x is 2x. 2 times 2 is plus 4, minus 3x equals 30. 2x minus 3x actually gives me a negative x, plus the 4 equals 30, and that's just combining my x's, or my like terms. Now I want to get x by itself, so the first thing I need to do is subtract 4 from both sides, and that gives me negative x equals 26. But I don't want to know what negative x is. I want to know what positive x is, so you can think of this as a negative 1 times x. You can either multiply both sides by negative 1 or divide both sides by negative 1, however kind of makes sense in your head. But my final answer should be that x equals negative 26. Okay, example 6. So again, we've got a lot of fractions. Except for now we actually have our variables in the denominator, but we're going to do the same thing we did last time. We need to find our least common denominator. We have this 2x, 7, 14, and just x by itself, or 1x. And so in that same process, to find my least common denominator, I kind of look at just the coefficients first. So 2, 7, and 14, my least common denominator across 2, 7, and 14, or the least common multiple of those three numbers, 2, 7, and 14, is going to be 14. But then I also have an x variable, so I'm going to have that x as well in the least common denominator. So, again, there's different ways to do this. I'm going to multiply both sides by that least common denominator, so by 14x. And just remember, you need to distribute it to all parts of the left and right side. Okay, so that leaves me with let me just undo that. That leaves me with 14x times the 5 over 2x minus 14x times the 4 over 7 equals, and I'm just distributing that across. You may not need to write this step. You might already start simplifying, which again is okay. Just be careful that you don't make any careless errors. 3 over 14, so 14x times the 3 over 14 minus the 14x times 2 over x. So in this step, I'm just going to have a lot of stuff canceling out. So 14x divided by 2x, the x's are going to cancel out, and 14 divided by 2 gives me a 7 times 5 in the numerator, minus here, I don't have any x's in the denominator, but I do have a 7, so 14 divided by 7 gives me 2x in the numerator times that 4. And then on the right side of the equation, the 14s are going to cancel out and become 1, so I'm left with just x in the numerator times that 3. And then the last part, I've got an x in the numerator and an x in the denominator that will cancel and become 1. So just a minus 14 is left times that 2. Now let's just go through and clean this up. So that's going to give me, let's see, 35 minus 8x equals 3x minus 28. Again, I want to get my x's together on the same side of the equation, so I'm going to subtract 3x from both sides. So on the right side, that becomes 0, so I'm left with 35 minus 11x equals negative 28. Now, to get this x by itself, I'm going to subtract 35 from both sides. I'm left with negative 11x equals 63. Negative 63. Sorry, negative 28 and negative 35 gives me negative 63. Now my last step, if I have negative 11x, divide both sides by negative 11. And I'm left with my final solution being x equals 63 over 11. And yes, that is positive because we had that negative divided by a negative. Okay, this next example, example number 7. Again, we have some fractions, but here our denominator, and remember this is technically a denominator of 1 because 4 is 4 over 1. So we have x plus 2 as a denominator. Also, again, an x plus 2 and then a 1. So the least common denominator is just going to be that x plus 2. It's going to be x plus 2. So again, with my method, I just multiply both parts by this x plus 2. So I'm going to multiply the left side and then both parts of the binomial on the right side. So that gives me the x plus 2 times 3 divided by x plus 2. So I'll write it out. You might not need this step. Times 3 over x plus 2 equals x plus 2 times the 5 over x plus 2 minus 4 times the x plus 2. Okay, so here I'm going to have x plus 2 divided by x plus 2 just cancels out and gives me 1. X plus 2 divided by x plus 2 just cancels out and gives me 1. So I'm left with 3 equals 5 minus this 4 times x plus 2. So now, before I can finish, I do need to distribute this minus 4 across this binomial. So I have 3 equals 5 minus 4 times x is going to give me minus 4x. Minus 4 times 2 is going to give me minus the 8, which simplifying the right side of the equation, we've got this positive 5 and this minus 8, so it's going to give me negative 4x minus 3. So now I just have a single variable equation. So I want to get this x by itself, so I can add 3 to both sides. That leaves me with a 6 on the left side. These cancel out. I'm left with just negative 4x on the right side. Divide both sides by negative 4. And then I get that x equals negative 6 over 4, which I know simplifies to 3 over 2. And that's because 6 and 4 both are divisible by 2, right? Okay, so yeah, my final answer is just negative 3/2. Okay, our next example, example number 8. Again, we need to find, as soon as I see fractions, I always like to go ahead and just get it all in the numerator. So find that least common denominator. So here I have a denominator of 6, a denominator of 12, and technically a denominator of 1. So the least common denominator of 6, 12, and 1 is going to be 12, because that's the least common multiple of 6 and 12. So, oh, it just went back. Okay. So what I need to do here is multiply both sides by that least common denominator of 12. So then I have, whenever I distribute across to each part, that gives me 12 times 1 over 6x minus, so we've got minus 4 times the 12, which is going to give me minus 48, equals, and then I'm going to have my 12 times 5 over 12x. So here, 12 divided by 6 actually just simplifies to 2x minus 48 equals, and then these 12s cancel out, so equals 5x. And again, many of you would have probably done that step in your head, but that's okay. Okay, now I just need to get my x's on the same side of the equation, so I'm just going to subtract 2x from both sides. This becomes 0, so I'm left with negative 48 equals 3x. Divide both sides by 3, and I end up with x equals negative 16 as my final answer. Okay, so example number 9. It's kind of like some of the earlier ones. So first thing we want to do is go ahead and simplify this equation before we start trying to solve for anything. So I'm going to go ahead and distribute this 2y across, so everything else is just going to come along for the ride. So 1 minus 5y plus 2 times y gives me plus 2y plus 14 equals 2y plus, and now I need to go ahead and distribute this 5 across the binomial. So 5 times 3 gives me 15. Minus y times plus 5 is going to give me minus 5y. Okay, now combine like terms. So I've got negative 5y and plus 2y. So that's going to give me a negative 3y. I also have 1 and 14, which I know gives me 15 on the left side of the equation. Over here I've got 2y and minus 5y, which gives me negative 3y, and then plus 15. And before I go on here, so my next step would be to combine, get my y's on the same side of the equation, and then solve for y. But right here, before I go on, I want you to recognize what's going on here. So again, our solutions are values of y that make this equation true. So I have right here the exact same equation on the left side or expression on the left side as I do on the right side. I have minus 3 times the unknown plus 15. If I plug in a 1 value for y, then I would have negative 3 times 1, which is negative 3, plus 15, which gives me 12. 12 will always equal 12. No matter what value I put in for y, if I multiply it by negative 3 and add 15, it will equal itself that y value multiplied by negative 3 and adding an additional 15. So right here, I start to see that there's more than one single solution for this. So if you think of what numbers I could put in there, well, since what we know about the real numbers that we've worked with so far, and so any values, I could put in a whole number, I could put a rational number in for y, I could also put pi in for y, I could put in any irrational number, the square root of 2, anything will result in some number where I multiply, some real number, if I multiply it by -3 and add 15. The other way you're going to see that this has actually an infinite number of solutions, which we actually write as, you can either just write the r or you can write it out as all real numbers. But this next step is where you'll see. So this is, if you hadn't caught that in that step, as soon as I tried to then add my 3y to both sides to get those y's on the same side of the equation, you would have been left with 15 equals 15. As soon as you end up with any number equals itself without a variable, so you eliminate that variable, that's another cue that 15 will always equal 15. No matter what value I pick for y, 15 will always equal 15. So there's no other restriction like some of the earlier problems we worked through. So instead of just having one single solution, this actually has an infinite number of solutions, which is any real number, all real numbers. Okay. So these last few equations are a little more just giving kind of an equation with a lot of variables in it or some different formulas and solving for a specific value. This could be very helpful if you have a formula and you have, maybe you know what in this case C is, an easy way to kind of rewrite the formula so that you could easily solve for some other components. So this is saying to solve for C, so this C is down in a denominator here. And so my first steps, I'm going to go ahead and rewrite. So I've got 1 over A equals 1 over B plus 1 over C. And the first thing you want to do is find that least common denominator. Anytime you see fractions and you're solving, go ahead and find that least common denominator. Since I don't know what A, B, and C are, my least common denominator is going to be ABC. All right. So I'm going to multiply both sides of this equation by my least common denominator, which is ABC. So I'm going to have, when I distribute this to both sides of the equation, I'm going to have ABC divided by A equals ABC divided by B plus ABC divided by C. So now, as you see, there's a lot that cancel out. So we've got A over A becomes 1, B over B becomes 1, and C over C becomes 1. So I'm left with BC equals AC plus AB. Well, again, remember, I actually want to solve for C. So just like my other problems, I need to get the C's on the same side of the equation. So I'm going to subtract AC from both sides. Okay, so now subtracting the AC from both sides, I'm left with BC minus AC on the left side equals AB. So a kind of clever move right here, and you're actually going to see this move a lot in algebra throughout this course, is I can factor out my C, so kind of undoing the distributive property. I can rewrite this left side as C parentheses B minus A. So you kind of, if you think of it as undoing the distributive property, that gives me my B times C for the first part, and the minus A times C for the second part. This all equals AB, and then once I just have this as C times something, even though my something is B minus A, to undo that and get this C by itself, I can divide both sides by that something, by the B minus A. And then this cancels out. I'm left with just C equals A over B divided by B minus A. And that is my final solution. Example 11, again, this is, you probably recognize this formula. This is the circumference of a circle equals 2 pi r. And in this example, we ask to solve for r. So I want to solve for r. So this one's a little bit easier. If I want to get r by itself, right now r is not by itself because it's being multiplied by 2 and pi, or 2 times pi. So if I want to get r by itself, I just need to divide both sides by 2 pi. And I'll be left with r equals c over 2 pi, or the circumference over 2 pi. The radius equals the circumference over 2 pi. Usually we write the r equals first, but either are correct. So r equals c over 2 pi. That is my final solution. Then last example, final example, finally, in solving for section 1.1, part 1, solving single variable equations. This last one is actually a relationship between Fahrenheit, degrees Fahrenheit and degrees Celsius. So F equals 9/5 C plus 32. So let's say that we wanted to solve for C. So I want this equation in terms of Celsius. So again, I want to get the C by itself, so I should subtract 32 from both sides. So I'm left with F minus 32 equals 9/5 C. There's different ways to kind of get rid of this 9/5. You could take each step, multiply both sides by the 5, then divide both sides by the 9. But I immediately noticed that if I want to multiply by the inverse, I can just multiply both sides by the reciprocal or the inverse of 9/5. So multiply both sides by 5 over 9. So that gives me that divided by 9 and also gives me that multiplying by 5. So I'm left with just C equals 5/9 times F minus 32. Which then my final step, just to have it in simplest form, I mean, you could leave it there. You could also, I guess, distribute across. I actually think in my math lab I will write it with C equals first. But either way should be fine. So 5/9 times F minus 32 would be a simple enough form because all it says is to figure out what C equals. So that is the last example of this lecture video. Make sure you're prepared with your notes for class to take a quiz on this lecture, so make sure your notes are in your notebook, handwritten. Also, now would be a good time to go ahead and start the homework for 1.1 part 1 and maybe go through all the examples and see if there are any initial questions you have or any ones that you have trouble with.